Dr. Babasaheb Ambedkar Open University.
Namaskar dear students. Welcome to the module on Introduction to Cross-Platform Application Development. I am Dr. Himanshu Patel, working as an assistant professor in School of Computer Science of Dr. Babasaheb Ambedkar Open University, and I am your instructor for this module. In this module, you are going to learn what is cross-platform application development is. You can know the history of Flutter application development. We will understand what is Flutter and you can list key features of Flutter. You can also enumerate advantages, disadvantages and various applications of Flutter, and you can describe Flutter features and understand Flutter architecture. So let us start with what is cross-platform application development. Cross-platform development is the practice of creating software applications that can run on multiple operating systems or platforms such as Android, iOS, Windows, Macintosh, Linux, etc. but using a single code base. Instead of writing separate versions of an app for each platform, cross-platform development allows developers to write the code once and deploy across multiple environments with minimal changes. Now let us try to understand key benefits of cross-platform development. You can see the list on screen. The first advantage is code reusability. Developer can reuse large portion of the code across different platforms, which saves time and effort. The second advantage is cost efficiency. It reduces the cost of development since one team can handle both iOS and Android or any other platform rather than separate team for each platform. The third advantage is consistent user experience. With shared code base, it is easier to ensure that the app provides consistent experience across all platforms. Another advantage is faster time to market. Since the code is written once and deployed across multiple platforms, the development cycle is shorter. Another advantage is easier maintenance. Any updates or bug fixes can be made in one place and applied across all platforms simultaneously. Now let us try to look at some of the popular cross-platform development frameworks. Obviously, we are going to learn Flutter, which is developed by Google. It uses Dart language and provides native performance, expressive user interfaces, and faster development cycle. Another popular framework is React Native, which is built by Facebook, and it uses JavaScript and allows developers to build mobile apps that work across platforms. Another popular framework is Xamarin, which is owned by Microsoft, and it uses C# and enables code sharing across iOS, Android, and Windows. The fourth framework for cross-platform application development is Ionic, which is based on Angular, and it allows building hybrid mobile apps with web technologies. Now let us try to understand how this cross-platform application development works. So there are two working models used by cross-platform frameworks. First is abstraction layer. So cross-platform frameworks provides an abstraction layer between apps code and underlying platform APIs, which allowing the app to work on different platforms without having to re-implement platform-specific code. So first is abstraction layer. Second is native and hybrid approaches. Some framework like React Native and Flutter provides near native performance by compiling to native code, while others like Ionic are more web-based and rely on browser environment within the app. Let us try to understand what are the challenges for cross-platform development. Major challenges faced by the cross-platform application development are: first, performance. So some cross-platform frameworks may not achieve same level of performance as fully native apps, especially in complex or resource-intensive applications, right? Second disadvantage or challenge is platform-specific features. While most frameworks provides access to common device features, developer may need to write platform-specific code or plugins for some unique functionalities. And third challenge is UI consistency. Ensuring native-like look and feel across different platforms can sometimes require additional work, which is cumbersome. Now let us try to understand what is Flutter is. Flutter is an open source user interface software development kit or SDK created by Google. It is used to develop cross-platform application from single code base. This means that with Flutter, you can build apps for Android, iOS, web, and desktop, which may include Windows, Macintosh, Linux, and even embedded devices, all using the same code base. Flutter is a framework that allows developers to build natively compiled applications across multiple platforms using single programming language called Dart. The framework includes rich set of pre-designed widget tools and libraries that help developers to create visually appealing and highly responsive applications. The use of widget in Flutter is essential to its design, making it easy to customize and create consistent look and feel across different platforms. Flutter represents significant shift in how developers can create applications across multiple platforms by providing a single code base that works on mobile, web, desktop, and embedded systems. Flutter offers versatile, efficient, and powerful solution for modern app development. Whether you are a beginner or an experienced developer, learning Flutter can open up new opportunities and streamline your development process. Overall, Flutter is popular among developers for its ability to simplify the process of building cross-platform applications, reducing development time and effort while delivering high-quality, natively compiled applications. Let us try to understand history of Flutter, how Flutter has evolved. Flutter has an interesting history that reflects Google efforts to streamline and modernize app development across multiple platforms. The first phase is initial development and announcement phase, which is between year 2015 to 2017. In year 2015, Flutter began as an internal project at Google under the code name Sky. The initial goal was to create a platform that could render consistently at 120 frames per second on Android. In May 2017, Flutter was officially announced at Google I/O 2017. At this stage, it was still an early alpha version. Google introduced Flutter as a way to build high-performance, high-fidelity mobile apps for iOS and Android from a single code base. Second, beta and preview release was launched in 2018. In February 2018, Flutter reached its first beta release. This was significant milestone as it marked the SDK readiness for broader developer adoption. During this time, Google emphasized the benefit of Flutter's fast development cycle, expressive and flexible user interfaces, and native performance. In May 2018, at Google I/O 2018, Google announced the release of Flutter Beta 3. This version includes support for Visual Studio Code, new widgets, and improved documentation, making it more accessible and feature rich. The stable released was released in December 4th of 2018, which is Flutter 1, which is released at the Flutter Live event in London, which marked the official stable release of Flutter, making it production ready for developers to use in building commercial app. The launch was accompanied by growing ecosystem of packages and plugins enabling developers to integrate various functionality into their apps easily. In the year 2019 and 20, it was expanded to web and desktop. In May 2019, at Google I/O 2019, Google introduced Flutter for Web, a technical preview that extends Flutter capabilities to web applications. This was part of broader strategy to make Flutter truly cross-platform framework. In the year 2020, Google further expanded Flutter to include support for desktop platforms like Windows, Macintosh, and Linux. These developments were part of Flutter Everywhere initiatives, aiming to provide unified development experience across all major platforms. In the year 2021 to present, Flutter 2.0 and other versions are released. In March 3, 2021, Google released Flutter 2.0, a significant update that includes stable support for web applications and improved experience for desktop applications. These versions also introduce Flutter developer tools, providing developers with better tools for debugging and performance optimization. In September 2021, Flutter 2.5 was released, bringing performance improvements, better development tools, and updated material design components. If we talk about recent development, which is from year 2020 to present, Flutter continues to evolve with regular updates, introducing new features, performance enhancements, and expanding support for new platforms and devices. The community and ecosystem around Flutter have grown significantly, making it one of the most popular framework for cross-platform application development today. So this was Flutter history, which reflects its evolution from an experimental project to a fully fledged framework that is now widely adopted for building applications across a variety of platforms. Now, let us try to understand key features of Flutter. The first feature is Dart language. Flutter apps are written in a Dart programming language, which is also developed by Google. Dart is designed for fast and efficient app development. The second advantage is widgets. Flutter is based on rich set of customizable widgets, which are the building blocks of the user interface. Everything in Flutter, we can say, is a widget, from buttons to padding to layouts. The third advantage is hot reload. Flutter offers hot reload feature, allowing developers to see changes in real time without restarting the app, making the development process faster and more efficient. The next advantage is performance. Flutter apps are compiled directly to native ARM code, meaning they can achieve high performance similar to native apps. Another advantage is customizable user interface. Flutter allows for highly customizable and flexible user interface designs. Thanks to its widget-based architecture, developer can create visually rich custom user interfaces that look consistent across different platforms. Another advantage is strong community and ecosystem. Being an open source project, Flutter has a large and active community with many third party packages and plugins available to extend its functionality. Flutter uses graphics engine to render visuals, which ensures high quality smooth animation across all platforms. Cross platform application development that we have already discussed. So let us try to understand advantages of Flutter. Major advantage of Flutters are displayed on screen. Obviously, the first advantage is cross-platform development. Another advantage is single code base. With Flutter, developer can write single code base and deploy it across multiple platforms, maybe iOS, Android, web, or desktop, which significantly reduce development time and efforts as we have discussed earlier. Then there is a consistent user interface and user experience. Flutter provides consistent look and feel across platform, ensuring uniform experience. Then there is a high performance. Flutter compiles to native ARM code, which ensures high performance and fast execution on mobile devices. Another advantage is GPU rendering. The framework uses the Skya graphics engine, enabling smooth and fast UI rendering even for complex animations. Another advantage is hot reload. Flutter's hot reload features allows developer to see changes instantly without restarting the app, which accelerate development, debugging, and experimentation. Then there are rich set of widgets available and customizable user interface components. Flutter comes with a wide range of pre-designed widgets that are highly customizable, enabling developer to create complex and visually appealing user interfaces. Flutter widgets adapt to design convention of the target platform, such as Material Design for Android and Cupertino for iOS. Being an open source project, Flutter has large and active community which contributes to a growing ecosystem of libraries, tools, and resources. Then there is extensive documentation available for Flutter. Flutter offers comprehensive documentation, tutorials, and supportive community, making it easier for developers to learn and solve problems. Then there is a flexibility and customization. We can create custom animation. Flutter provides powerful tools for creating custom animation and transition, allowing developers to build engaging user experiences. Flutter supports integration with wide range of third-party services and libraries, expanding its capabilities. Now, let us try to understand disadvantages also. On screen, you can see disadvantages of Flutter. Flutter has some limitations, such as large app sizes and potential challenges in managing complex projects. When considering Flutter, it is essential to weigh these pros and cons based on the specific needs and goals of your project. Why there is a large app size? Flutter apps tend to have large binary size compared to native apps due to the inclusion of the Flutter engine and framework libraries. This can be a concern for users with limited storage space. Then there are limited native APIs available. So, to use platform specific features, Flutter provides access to many native features. Some platform specific APIs might require additional work, such as writing native code or using third party plugins. New features and API released by iOS or Android may take time to be fully supported in Flutter. Another disadvantage is complexity for larger projects. First issue is scalability. For very large and complex applications, managing single code base across multiple platforms can become challenging. Why? Especially if there are significant differences in platform requirements. Another disadvantage may be state management. So, managing state in Flutter can become complex in large applications, requiring careful planning and use of state management. Flutter uses Dart, which is not as widely adopted as other languages like JavaScript, Swift, or Kotlin. So, developers unfamiliar with these language may face learning curve issue. Then there may be disadvantage of custom development practices. Flutter approach to UI design and development is heavily relies on widgets, which may require developers to adapt to new design patterns and practices. Then there is a limited web and desktop support. While Flutter has expanded to support web and desktop applications, these platforms are still not as mature as mobile support, leading to potential limitations or bugs. Then there may be some performance issues also. Web and desktop apps built with Flutter might not yet match the performance and feature parity of those built with native or other mature web or desktop frameworks. So these are the disadvantages of Flutter. Now let us try to understand various applications of Flutter. Cross-platform development is ideal for businesses or developers who want to reach wide audience quickly and efficiently while minimizing the efforts to manage different versions of an app. Flutter is used widely for various types of applications, including mobile applications, web applications, desktop applications, and embedded applications. With Flutter, developer can create high-performance mobile applications for both Android and iOS. We can also create web applications. Flutter for Web allows developer to create web apps with the same code base used for mobile apps. We can also create desktop applications for Windows, Macintosh, and Linux. You can also use same code for embedded applications also. Flutter can be used for embedded devices, offering the potential for wide range of IoT, that is Internet of Things applications. Now let us try to understand Flutter architecture. Flutter is a cross-platform user interface toolkit that is designed to allow code reuse across operating systems such as iOS and Android, while also allowing applications to interface directly with underlying platform services. The goal is to enable developer to deliver high performance apps that feel natural on different platforms, embracing differences where they exist while sharing as much as code possible. During development, Flutter apps run in a virtual machine that offers stateful hot reload of changes without needing a full recompilation. For release, Flutter apps are compiled directly to machine code, whether Intel x64 or ARM instruction, or to JavaScript if targeting the web. The framework is open source with permissive BSD license and has a thriving ecosystem of third-party packages that supplement the core library functionality. Let us try to understand architectural layers of Flutter. So, Flutter is designed as an extensible layered system. It exists as a series of independent libraries that depends on underlying layer. No layer has privileged access to layer below, and every part of the framework level is designed to be optional and replaceable. On screen you can see Embedder, which provides functionality which is platform specific. To the underlying operating system, Flutter applications are packaged in the same way as any other native application. A platform specific embedder, you can see on the screen, provides an entry point, coordinates with the underlying operating system for access to services like rendering, accessibility, and input, and manages the message event loop. The embedder is written in a language that is appropriate for the platform. Currently, Java and C++ for Android, Objective-C or Objective-C++ for iOS, and Macintosh OS, and C++ for Windows and Linux. Using the embedder, Flutter code can integrate into existing application as a module, or the code might be the entire content of the application. Flutter includes number of embedders for common target platforms, but other embedders also exist. At the core of Flutter is Flutter Engine, which is mostly written in C++ and supports the primitives necessary to support all Flutter applications. The engine is responsible for rasterizing whenever a new frame needs to be painted. It provides the low-level implementation of Flutter's core API, including graphics, through Impeller on iOS and coming to Android and Mac OS and Skya on other platforms. Text layout, file and network I/O, accessibility support, plugins, architecture, and Dart runtime and compile tool chain. The engine is exposed to Flutter framework through Dart UI, which wraps underlying C++ code in Dart classes. These libraries expose the lowest level primitives such as classes for driving inputs, graphics, and text rendering subsystems. Typically, developers interact with Flutter through the Flutter framework, which provides a modern reactive framework written in the Dart language. It includes a rich set of platform, layouts, and foundational libraries composed of series of layers working from the bottom to the top. We have basic foundational classes and building blocks, services such as animation, painting, and gestures that offers commonly used abstraction over the underlying foundation. The rendering layer provides an abstraction for dealing with layout. With these layers, you can build a tree of renderable objects. You can manipulate these objects dynamically with the tree automatically, updating the layout to reflect your changes. The Vigate layer is a composition abstraction. Each render object in the rendering layer has a corresponding class in the Vigates layer that you can see on the screen. In addition, the Vigates layer allows you to define combination of classes that you can reuse. This is the layer at which the reactive programming model is introduced. Then there is a Material and Cupertino libraries, which offers comprehensive sets of controls that use Vigates layers composition to implement Material or iOS design languages. The Flutter framework is relatively small. Many higher level features that developers might use are implemented as a packages, including platform plugins like Camera and WebView, as well as platform agnostic features like HTTP and animation that built upon the core Dart and Flutter libraries. Some of these packages come from the broader ecosystem covering services like in-app payments, Apple authentication, and animations. Let us sum up. In these modules, we have discussed what is cross-platform application development and list some popular framework for it. You have got detailed explanation of Flutter and its key features, advantages and disadvantages of Flutter, and we also discuss overview of Flutter architecture. I hope you enjoyed this session. Thank you for your attention and happy learning.
स्वाध्यायः